Hi, in this video we are going to talk about the splaying method. And what's the aim of this splaying method? That we make sure that this node after the splaying method is going to be the root node. Why is it good? Because this is exactly how caches work. The recently searched items is going to be the root node or near the root node. So while the node getParent is not equal to null, what does it mean? If the node.getParent is a null, it means that this is the root node. So basically, while this node is not equal to the root node, of course we have to make some rotations until we bump into the situation when this node is equal to the root node. This is the aim of splaying. And we have been talking about the zig situation, the zigzag situation, and the zigzag situation in the theoretical section. So basically, this is the zig situation, where the node.getParent is a null. What does it mean? That the grandparent is a null. It means that the given node is the left child or the right child of the root node. So of course we just have to make a simple right rotation or left rotation to make sure that the node is going to be the root node, because the aim is to make sure that this node is going to be the root node. So if the node.getParent node.getLeft node is equal to the node, what does it mean? That this given node is the left child of the root node. So we have to make a right rotation on the root node. The nodes.getParent node is the root node, because we know that the grandparent is a null, so the getParent has to be the root node. And if we make a simple right rotation, then this node is going to be the root node. This is the aim of splaying. This is what we are after. Else we know that the node is the right child of the root node and the grandparent is null, so we just have to make a simple left rotation on the node's getParent node, which is the root node in this case. This is the zig situation as we have discussed in the theoretical section. We have a zigzag situation and a zigzag situation. Whenever the node's getParent node, getLeft node is equal to the node, it means that when the node is a left child, and basically the parent is the grandparent's left child, so the given node is a left child and the parent is a left child, then we have to make two right rotations. And this is what we have been discussing in the theoretical section, that every case has a symmetric partner. So basically they are in pairs. In this case it is a left child of a left child, but we can have the situation when it's a right child of a right child. We have to do the same. Of course, instead of rotating to the right and to the right, we have to rotate to the left and to the left. But the operation is exactly the same. Of course, we just have to use right whenever we use left and vice versa. So basically, this is the zig-zag situation. And we have the zigzag situation when the node getParent getLeft node is equal to the node. So the node is a left child, but the parent is a right child. So here, so both of them were a left child or both of them were a right child. Here, one of them is a left child and the other one is a right child, or vice versa. One of them is a right child and the parent is a left child. So then we have to make a right and a left rotations accordingly, because they are symmetric partners as well. So we have to make a right rotation and a left rotation, or a left rotation and a right rotation. And basically we have to make sure that we make these kinds of rotations until the node is going to be the root node. Okay, so while the node getParent node is not equal to null, we have to make the zig situation, the zigzag situation, or the zigzag situation accordingly. So that's all about the splay method. I don't want to repeat myself over and over again, but just to summarize again. The aim of the splaying is to make sure that the node is going to be the root node. Why is it good? Because if it's the root node or nearby, then the search is going to be done very fast. We don't have to traverse the whole tree, for example. Let's consider that we built a tree-like structure, a splay tree, for example, with the users of Facebook. We have millions and millions of users, so it doesn't matter whether we have to consider the root node or the nearby nodes of the root node, or we have to traverse the whole tree, for example, and we have to consider lots of possibilities. So with the help of splaying, we make sure that the node is going to be the root node or somewhere there. And it's very important that here we have to make rotations. Okay, you may come to the conclusion that we have to make rotations for AVL trees and red-black trees, but here we are not going to make rotations in order to make the tree balanced. We make rotations in order to make sure that the node is going to be the root node. It may happen that, for example, after the splaying, the tree is going to be much more unbalanced than it was before the splaying operation, but it doesn't matter. We don't want to make this tree to be balanced because we would like to implement caches with the help of splay trees. So that's all about the splay operation. Thanks for watching.